Hello everyone. Today we'll be discussing about the sorting algorithms, and my teammates are Alejandro, Christopher, Daniel, Shifra, and myself, Sonali. Sorting is way of arranging the data or the elements in a particular format, that is either in ascending order or a descending order, in whichever way you want. So basically, there are several different types of algorithms used in the sorting techniques like bubble sort, insertion sort, selection sort, merge sort, quick sort, and heap sort. Among them, we'll be discussing today the bubble sort and the merge sort algorithms. So bubble sort is one of the simplest algorithm which keeps on trying two of its adjacent elements, like the first element and second elements, compare it. If there is a swap is needed, it swipes the element. So you keep on repeating the steps unless the whole list is arranged. So we'll discuss with an example. So here is the code for how to run a bubble sort. So this is a list with n elements, that is the 5 elements. So first I create a for loop, which is I in range of n. So here range of 5 is because I have 5 different elements. So my first iteration will start when I equals to 0, and then the second for loop, the inner loop, that is from j in range of 0 to n minus I minus 1, that is 5 minus 0 minus 1, that is 4. So what exactly we do is array of j is greater than array of j plus 1. So now my j is 0. I compare my 5 is greater than 4. Yes, 5 is greater than 4. So I do the swapping. So 4 goes to the fifth, to the 0th position, and 5 is moved once left, right to the 4th position. Same thing, now I increment my j value to 1 and try to check with the adjacent element, that is 5 and 4. So here array of j, that is array of 1, is greater than array of j plus 1, that is 1 plus 1, 2. So here 5 is greater than 1. Yes. So I do a swapping over here. Next, my j is incremented to 2, and I check 5 is greater than 3. Yes, 5 is greater than 3. So here a swapping happens. And once that is done, next j is incremented to 3 now. So now 5 is greater than 2, condition becomes true, and here we do the swapping. So after my first iteration, you can see the largest element is at the end of my list. So I have done, after iteration 1, my first element is in its position. So now I'm going to do the second iteration. And now here I'm going to start my ith value, I'm going to increment to 1. And I'm going to compare all the elements only from the 0 to 4, because now already my fifth position with the 5 is already in its position. So I don't need to go back and check. So for that purpose, I'm doing n minus I minus 1, because each time that I go to the second iteration or third iteration, I keep on reducing the size of my array. So here I compare, my j is now 0. I compare my 4 is greater than 1. Yes. So 4 is the swapping happens here. Now next my j is incremented after the if condition. So that is 1. J is 1 now. So 4 is greater than 3. Yes, the condition becomes true. Here the swapping happens. Then again I check when j is 2, my 4 is greater than 2. Condition is true, and my 4 is in its position now. So you can see the number of iteration in the second are less compared to the first one, because first one was going from J0 to J4, now J0 to J3. Same thing, I keep repeating my IE now. I'm done with executing my inner loop. Now I'll increment my outer loop, that is I. So once that is done, my I equals to 3. Then I compare my first element, that is 1 greater than 3. No, the swapping don't happen. So now I increment my j value to 1 and compare 3 is greater than 2. Condition becomes true. 3 is swapped here and 2 in this position. So after my third iteration, I increment to I value to 3 now. So same thing I do here. 1 is greater than 2. No. 1 is not greater than 2, I don't do any swapping, but at the end position j equals to 1, I get complete sorted list. I get the final list over here. So in this bubble sort, you can see I'm using 2 for loops to compare the elements with its adjacent element, and I'm doing the swapping. So this is the code to run the to print and run the sorted algorithm. I'm calling here bubble sort function, what I wrote in from the previous slide. So you can, since I'm using 2 for loops, so the time complexity is O of n square over here. So this is not a recommended algorithm because it is taking n square times to run run the array. So for example, if you have a list of 20 or a 40 elements in it, so it is going to repeat like 400 steps if it is 2400 steps. So you can see how many times of the iteration is repeating. So what we do is like we have the another method called as merge sort, which is much widely used than the bubble sort. This is the actual code of the bubble sort. So next is the merge sort. So merge sort algorithm is a divide and conquer algorithm. Why we call it as a divide and conquer? Because the whole list you keep on dividing into 2 halves unless it has a single element. You can see here like 38 and 27. Once all the elements are split into single element, then you compare those elements, and after comparing, you merge them together. So this is like dividing and then doing the conquer techniques. So this is, so we'll discuss about this here. So this is the code for the merge sort algorithm. So here I'm solving this problem using the recursive technique. Here I'm first finding the length of my list, that is 7. 7 is my length of the list. And then I'm comparing if length of the list is 1, then I'm going to return. So this is the base case for my recursive function. So once it is 1, I'm going to stop over there. Till then, I keep on dividing into 2 halves. So I'm going to find the mid value, that is length of list by 2. So I'll find the mid value over here. I'll find the mid value here, mid value in this position. So everywhere every time I divide the list, I try to find the midpoint and then divide the further. So I will end up having the left partition and the right partition. So my left partition, like I'm calling the merge sort function till I get a single element. So that is from the start to the mid element will be my left partition, and my right partition will be from mid element to the last element. So for example, if I call the partition over here, my left partition will be 38 and my right partition will be 27. Same if I compare with this 38, 27, 43 and 3, you can see my left partition will be 38 and 27 and my right partition will be 43 and 3. So same thing from here, if you compare the whole list, you can see 38, 27, 43, 3 is my left partition, and 9, 82, and 10 is my right partition. So once I divide it, I'm going to merge. I'm going to call the merge function that I'll explain you in the next slide. I'm going to merge my left partition and right partition. That is where the merging technique happens. This is just dividing each element, list into each element. So once that is done, now I'm going to compare my 38 and 27 and try to find. So how I do this? First, I do all the left side, then I do the right side. So here I'm calling my left merge, merge of left side and the right side. So I'm creating an empty list, that is the output. I'm giving it a name as the output, and I'm having the 2 pointers, that is I and j is equals to 0. I'm initializing them. So here I'm using the while loop because I have to iterate through all the elements from the start to the end. So now I know j is 0. 0 is less than length of left. So we are here at the 38th position. So length of left is 1 right now. And j is 0 is less than length of right. That is 1. Length of right is 1 because 27 is the only element. I'm comparing now. 38 is less than this if condition. 38 is less than 27. No, condition is false. So I go to the else parts and then output dot append right of j. So now I append my 27 to this output. 27. And then I'm incrementing my j pointer to 1. So it was 0. Now the j pointer will become 1. So my j pointer is 1. Now the while condition becomes false because my 1 is less than 1. The condition becomes false. So I come out and execute the step 11. That is output dot extend. So whatever the elements are left will be added back to my output. So 27 and then the 38 will be added back. And it also does the output extend, right? But there is no element, that's it. So 27 and 38, we got this array. Next, we had called the right merge also. So once the left happens, we do the right side, that is 43 and 3. Same thing you do and you get the output as 3 and 43. Once this part is done, so you get into this loop. So that time what happens, my length of list, now here you can see I will be again 0 and my j is 0 now, and my length of left is 2 and length of right is 2. So 0 is less than 2 and j is less than 2. Yes, condition left of 0, that is 27 is less than 20, less than 3. 27, no, condition is not true. So it goes to the output and appends 3. So 3 is appended to my output now. So same thing, I go here and when that is done, my j pointer is incremented. So now j will become 43. So now next is like 27 is compared with 43. 27 is less than 43. Yes, condition becomes true. Then output dot append left of I. So 27 is put in the appended and my I value is incremented to 1. So that is done. So next, now I is 1 now. So 1 is less than left. Yes, because left is 2. So now 38 is compared with output of j with 43. So 38 is less than 43. Yes, condition becomes true. Now 38 is appended to the output. And then once that is done, my pointer is incremented. So after the pointer is incremented, the while loop becomes false, and then the output dot extend left. Any element which is left will be added back to the list. So in the left, there is no element left, but in the right, yes, 43 is added. So once you execute the left side, then what happens is that it calls the right merge. So right side. So that is in the previous left right partition. Same thing you do on the left side. Once you do that, you get a sorted list. That is 3, 9, 10, 27, 38, 43, and 82. So here you're calling this merge function recursively. This is to run the code. And the time complexity for is n log n. The reason for n log n is because each time the whole list is dividing into 2 halves. So you keep on dividing into 2 halves. So it reduces the overall runtime for this algorithm. So it is n log n. And merge sort is much faster compared to the bubble sort and the insertion sort. Thank you so much. This is the actual code. And thank you.